Now we measure the expression of velocity and the total energy of electron in stationary orbit. Okay, that means we are again still in the topic called Bohr's theory of hydrogen and hydrogen-like atoms. Okay, so in the last YouTube video, we derived an expression of radius of the different orbit of an electron revolved in the atom, in an around the nucleus. Now, when electrons are revolving, okay, definitely they acquire a velocity, and that velocity are also different for different orbit. And when the electron revolve with a certain velocity, they are acquiring certain velocity, means they have certain kinetic energy, and they also acquire some position. And they also acquire what? Potential energy. But the kinetic energy and potential energy total is combined is called what energy? Total energy. So in this particular video, we derive an expression of velocity and the total energy of electron in what orbit? Stationary orbits. Okay, now for that we start with the expression that we have done it already, okay, in the last YouTube video. Okay, but to start with the expression velocity, as I said, so we start with the first postulates. You know what is the first postulate that we have learned? MBR equals to ns by what? 2 pi. So according to Bohr's first postulate, the angular momentum of the electron in any of the orbit is measured by ns by what? 2 pi. Okay, so from here only we can start with the expression of velocity. So I'll make B as the subject. If I make B as the subject, so I write on nh by 2 pi. Now this m and r will go in the denominator. M and r will go in the denominator. So children, you can see now B equals to nh by 2 pi mr. Okay, so this is the velocity of electron, but in terms of mass and the radius of the electron. But we have already measured the radius of electron in any of the orbit, and you know what is the formula that you learn? That is n square h square epsilon naught by what? Pi m z e square. So this is the expression of radius that we already derived in the last YouTube video. So let this radius I replace in the expression, so that we can measure this velocity even in terms of this atomic number. So B equals to nh by 2 pi m, now by into r, but what is r out here? N square h square epsilon naught whole divided by what? Pi m z e square. Okay, now this m and m cancel out, pi and pi also cancel out. Okay, so now what happened? This will be reciprocal, so I write on n h, okay, n h into z square will go in the numerator. So z e square will go in the numerator, it will be reciprocal. But in the denominator, what will remain? 2 n square is also there, h square is also there, and epsilon naught. Okay, now this n and 1n square cancel out, and this h and 1n h square cancel out. So B equals to what? Z e square by 2n h epsilon naught. So you can see the expression of velocity that we have obtained now is what? B equals to what? Z e square by 2n h epsilon naught. But I just write this expression and rearrange the expression in such a manner. So I write on this as z e square by 2h epsilon naught. I write them together into 1 by n. So that means this is the expression that measures the velocity of electron revolving any of the orbit. Any of the what? Orbit. But this relation, see, this measures the velocity of electron in any of the what? Orbit. But this relation of velocity shows that B is inversely proportional to n. B is inversely proportional to what? N. Because for a given atom, Z is constant, charge is also constant, H, E, everything is constant. This quantity is constant. This quantity is what? Constant for a given atom, which means B is inversely proportional to n. B is inversely proportional to n means that the velocity of electron, okay, is maximum in the first orbit. Maximum in the which orbit? The first orbit, also called lowest orbit, okay, and goes on decreasing to the higher orbit. When the number of orbit increases, the velocity of electron decreases. Means the electron which revolve in the first orbit or the lowest orbit move with the maximum velocity. But after that, when we go to the electron which are revolving in the second orbit or third orbit, and when you go to the higher orbit, the velocity of electron keep on decreasing. Okay, but we can calculate the velocity of electron in any of the what? Orbit. okay, for any of the what atom. Now once the velocity is acquired by the electron in any of the orbit, then that electron also acquire what energy? Kinetic energy. Now we come to the expression of the total energy, but total energy can be calculated in terms of what? Kinetic energy and what energy? Potential energy. Okay, so first we calculate what energy? Kinetic energy. And you know kinetic energy, okay, is actually given by K, and the kinetic energy for any body whose mass is m and moving with the velocity is given by the formula half mv square. So this is the expression of kinetic energy for the electron whose mass is m moving with the velocity what? b square. Okay, now this expression of kinetic energy can be expressed in terms of what? In terms of what? The atomic number. So kinetic energy this much, but you know one of the first equation that I had derived in the last YouTube video, and that is mb square equals to z square by 4 pi epsilon naught and r. See children, this is the first equation. This is the first equation that I have derived. So mb square equals to z square by 4 pi epsilon naught r. Now this mb square, now I replace by this z square by 4 pi epsilon naught r, which means a kinetic energy can be written as 1 by 2. This is 1 by 2. Now this mb square I write down as into z square by 4 pi epsilon naught r. Okay, now we can even write this kinetic energy now as z square by 2 4s are 8 pi epsilon naught and what r. So look at the expression kinetic energy. So kinetic energy acquired by the electron in any of the orbit, this is for any of the orbit, is equals to K equals to Z square by 4 pi epsilon naught what? R. But children, you know that the electron revolve in their different orbit with respect to the nucleus. The electron also acquires certain position. So that means the electron also has what energy? Potential energy. But this potential energy is actually called the electric potential energy, also called electrostatic potential energy. And electrostatic potential energy between the nucleus and the electron can also be calculated as U equals to, and symbol of U is electrostatic potential energy, equals to 1 by 4 pi epsilon naught. The charge of the nucleus, and that is plus Ze, positive charge. Charge of the electron, negative charge with minus E, by the distance between the electron and the nucleus is what? R. So children, just try to understand this relation. This formula which I have written is by using this formula. U equals to 1 by 4 pi epsilon naught Q1 Q2 by what? R. So yes, this formula you already learned in electrostatics. Okay, third chapter, electric potential and potential energy. When you measure electric potential energy, we have to consider charge also, because first charge is charge of nucleus, which is positive charge. The second charge is charge of electron, which is negative charge. That's why when you calculate potential energy, we have to consider the charge also, plus positive charge, another is negative charge. And what is the distance between the nucleus and the electron? R. That's why we divide by what? R. Okay, so now from here we can write down U equals to, the plus into minus is minus, okay, minus 1 by 4 pi epsilon naught. Now Z, this is Z. Now E into E means what? E square by what? R. So this is the relation that measures the electric potential energy. But it's still in this relation I write the relation, okay, as U only, minus 1 by 4 epsilon naught Z E square by what? R. But the total energy means what? The sum of kinetic energy and what energy? Potential energy. So we calculate total energy of the electron, that is E, as the sum of kinetic energy and potential energy. We know what is kinetic energy, that we have already calculated. Okay, the total kinetic energy is Z E square by, yes, 8 pi epsilon naught R. We have already calculated this one. Plus your potential energy means this one. So with sign I write on minus Z square by what? 4 pi epsilon naught and what? R. Okay, so let me multiply. Plus into minus is minus. So it is Z square by 8 pi epsilon naught R. Plus into minus is minus. So this will be Z square by 4 pi epsilon naught into what? R. Okay, now we can see what is the LCM of 8 pi epsilon naught R and 4 pi epsilon naught R. So LCM will be what? 8 pi epsilon naught R only. 8 pi epsilon naught R. So this denominator can be divided to the LCM. So remainder is 1. 1 into Z square means ZE square minus this quantity. If I divide to the LCM, your remainder will be 2 because 4 2 is 8. Or the quantity will cancel out. 2 into ZE square means 2ZE square. Okay. Now when you subtract, it will be minus ZE square minus 2ZE square means minus ZE square by 8 pi epsilon naught into what? R. So this is E. So this is what? E. So total energy is now equals to minus ZE square by 4 pi epsilon naught what? R. But children, the same expression of energy now we can write even in terms of the number of orbits. Okay. So for that I eliminate this R. See, R is the radius of the electron in any of the orbit. Okay. So let me just replace it in terms of N. So minus ZE square by 8 pi epsilon naught. Now you know R means what? N square H square epsilon naught. You have done it already. By pi, okay, M Z E square. Okay. So let me just do the cancellation because pi and pi cancel out. Okay. So the quantity will not cancel out. So this will be reciprocal. So E equals to minus ZE square. Now this mze square will go in the numerator. So mze square will go in the numerator by, so what is in the numerator? 8 n square h square. Now epsilon naught into epsilon naught, if you multiply this will be epsilon naught square. Okay. So just let me just rearrange and write it down. So E equals to, now this can also be written this way also. Now sign will be minus m, I write on m. Z into Z means what? Z square. E into E square into E square means E to the power 4. Okay, E to the power 4 whole divided by, I write on what? 8. Then after I write on epsilon naught square, h square. Then after I am writing n square. So this is the expression that measures the energy acquired by the electron, total energy acquired by the electron in any of the orbit in an atom. Okay. So this is for any atom, hydrogen atom or hydrogen-like atom, where n is the number of orbit and all. So this is the expression of total energy of electron in nth orbit. This is for what? Nth orbit, any of the orbit. So the energy, total energy of electron in any of the orbit is measured by, given by the formula minus m z square e to the 4 by 8 epsilon naught square h square n square. Okay. So we do this much today. Okay. Now we do continue with the other part of this particular topic called Bohr's theory of hydrogen and hydrogen-like atom. Okay, and that we do in the next class. Thank you.